Mining Industry by Gonzalo Ulloa Terán.
100 lectures of the mining process.
Cyber threats to the mining industry.
Automation in mining. Mining is a dangerous profession. In the 19th and 20th centuries, thousands of fatalities occurred from mine explosions and other accidents. Mine accidents stem from poisonous gas leaks, explosive natural gas leaks, dust explosions, structural collapse inside mines, earthquakes, flooding, malfunction of mining equipment, and the like. Today, mine safety, health legislations, advances in technology, and training has reduced mining deaths and injuries. The automation of hazardous, repetitive, and labor-intensive tasks is a key contributor in improving mine safety. A cyber attack against the mining industry that targets automated mining equipment and processes jeopardizes the safety and lives of miners. Autonomous operations started in the early 1990s. By the mid-90s, equipment suppliers were presenting buyers with options for automating equipment. Technology such as Global Positioning System, GPS, remote sensing, wireless communications, and high-speed telecommunications made automation viable. There are many driving factors behind mine automation. Mining is a series of discrete operations such as drilling, blasting, loading, hauling, and materials processing. The industry is moving towards low-grade, super-large, high-tonnage, and ultra-mechanized operations. This has created a need to increase yield through greater understanding and control of the production process. Automation increases the level of control in a highly variable and unpredictable environment by applying stringent rules to the decision-making process and removing randomness inherent in isolated decision-making. Mines have to be built where the ore bodies are located, oftentimes in remote locations. In today's competitive economy, mining companies are finding it increasingly difficult and expensive to attract and recruit skilled labor in unattractive locations. Automation allows staff to remotely operate equipment and oversee operations at the mining sites, and the mining company needs to maintain a smaller workforce at the actual mines. Automation also means a single operator can operate multiple machines, and this reduces overall operational costs. Ultimately, automation is a boon. It improves the safety of miners, reduces operational costs, brings production consistency, increases production capacity, increases the level of control at each stage of production, limits operational variance, improves precision, manages equipment wear and tear through real-time monitoring, allows for accurate process modeling, etc. Automation is suited to a number of key mining operations such as production drilling and the real-time recognition of materials being drilled, automated materials handling using equipment like haul trucks, loaders, diggers, shovels, conveyors, and sizers, automated and accurate movement of equipment, monitoring of moving parts for maintenance and diagnostic intervention. One of the most visible elements of the modern mine are automated haul trucks. Figure 8 Hitachi Autonomous Haulage System, AHS, elements. GPS antenna, LiDAR, AHS, control box. Millimeter wave radar, ARS power mode change switch, electric power steering module. Figure 9 Autonomous Haulage System Ecosystem, GPS satellite, fleet control, dumping site, safety, automatically stops when detecting obstacle, hauling road, Loading site. Accurate positioning is important for the remote operations of automated haul trucks. Onboard sensors generate real-time maps of the mine environment, geometry and geology around these trucks so they can be remotely operated for positioning. Above ground they will use a combination of real-time kinematic, RTK, Global Navigation Satellite System, GNSS, plus machine sensors, e.g., odometers, plus inertial guidance plus perception-based positioning, e.g., radar, laser, vision, and sonar, plus pseudolites, ground-based satellite or reference stations. Below ground they will use a combination of radio frequency-based distance measurements plus perception-based positioning, e.g., radar, laser, vision, and sonar, plus machine sensors, e.g., odometers, plus inertial guidance. These tools accurately locate and control the activities of the automated haul trucks. The position and status of all automated equipment in the mining site are fed to the central management system at the ROC. This allows for sophisticated process modeling and activity coordination that ultimately leads to improved mineral recoveries and lower costs. Any serious disruptions to the operations of automated mining equipment resulting from a cyber attack will take the mining operation offline, causing financial loss and possible equipment damage. With mines becoming automated, capacity increases are needed for the transfer and manipulation of huge amounts of data. Efficient data warehousing and data fusion solutions are needed for daily mining operations. This has led to the creation of the ROC. Figure 10 BHP. Billington Integrate ROC. Australia. ROCs enable supervision, control, analysis, and data acquisitions from remote mining sites. Improvements in telecommunications infrastructure, in particular telephone networks and fiber optic links, are key enablers for the development of ROCs. Business drivers for the development of ROCs include improvements in occupational health and safety by removing operators from risk exposure, reduced labor costs by relocating high-cost, knowledge-intensive staff away from mines to cities, increased productivity through identification of inefficiencies in operations, collaborative planning between functions, process visibility across the production chain, and the creation of centralized knowledge and experience hubs. Business integration with the regional offices and the head office to help them make fast and well-informed decisions. As mining and resource companies move into the next generation of remote operations, cloud computing, big data and analytics, and mobility, they will need to dramatically increase their security posture in order to maintain ongoing operations. The ROC serves as the nerve center of the modern-day mining operation. Cybercriminals planning disruptive or destructive cyber attacks against a mining company will attempt to compromise the ROC because the ROC serves as a single point of failure that can take the entire mining operation offline. Mining communication infrastructure. A mining communication system, MCS, is a network of devices that collect, receive, or transmit information. The MCS has three components: the information source or transmitter, the communication pathway or network, and the information receiver. Mines traditionally have multiple communication networks for the different applications and for fault tolerance. Networked mining equipment uses wireless, wired, or hybrid, wired and wireless, connectivity. Underground mining networks mostly rely on cables, but wireless networks are also extensively used. The following table compares the different communication technologies. Technology: VHF, UHF. Typical application: voice, data, tracking. Advantages: high bandwidth, can allow many users, accommodate high traffic, multiple voice channels, small and wearable antennas. Factors impacting safety are known. Disadvantages: best for line-of-sight applications, not good around bends. Technology: MF. Typical application: voice, data. Advantages: can turn corners, metal infrastructure, pipes, track, wires, etc. in the mine can help increase range, parasitic propagation. Disadvantages: limited bandwidth, existing electrical and communication system may cause interference, though not as much as for ULF, VLF, LF. Technology: ULF, VLF, and LF. Typical application: personal emergency devices. Advantages: can go through the earth. Disadvantages: natural phenomena, existing electrical and communication system can cause severe interference. Very limited bandwidth, requires surface or underground loop antennas. Technology: UWB. Typical application: tracking, data. Advantages: ideal for tracking, no interference from existing electrical and communication systems and multiple effects. Very high bandwidth, simple architecture, potential to be inexpensive. Disadvantages: very short range. Source: Nutler 2007, Sherry et al. 2008, Friedlos 2008, Swedberg 2008, NIOSH, N. D. A. Table 1. Comparison of the different communication technologies. The MCS uses a variety of communication system infrastructure: wired mesh systems, wireless mesh systems, RFID leaky feeder infrastructure systems, fiber infrastructure systems, and serial infrastructure systems. A successful MCS has the following attributes: can accommodate different types of information sources, can accommodate existing infrastructure, can accommodate information source mobility, supports safe, robust, and redundant operations, can be easily scaled up in size and allows for easy maintenance. One of the major applications of the MCS is mine monitoring systems. Mine monitoring systems are used for production monitoring, equipment status monitoring, and safety and environment monitoring. Monitoring system manufacturers typically have their own reporting applications. There are unified reporting applications that collate, process, and display information from all the different monitoring systems in the mine. To facilitate visibility across all the mine monitoring systems, received data from each system is fed into a central reporting database and further processed to get the unified picture. These reporting databases are valuable espionage targets for cyber criminals because they provide real-time status updates of the mining operation. Intersection of mining and oil and gas industries. We mentioned previously that in countries like Canada and Venezuela, oil sands are surface mined, processed, and converted into petroleum products. With oil sands production there is an intersection of mining with the larger and more complex oil and gas industry. In general, the oil and gas industry has four main segments: upstream, midstream, downstream, and service. Upstream, the exploration, recovery, and production of oil and natural gas. Midstream, the collection and transportation of crude oil, natural gas, and refined products. Downstream, the manufacturing, selling, and distribution of natural gas and products derived from crude oil. Service, companies that provide services to the oil and gas industry but do not produce petroleum or petroleum products themselves. Figure 12. Oil and gas supply chain. Upstream, midstream, downstream, and service. Upstream, the exploration, recovery, and production of oil and natural gas. Midstream, the collection and transportation of crude oil, natural gas, and refined products. Downstream, the manufacturing, selling, and distribution of natural gas and products derived from crude oil. Majority of the companies in the oil and gas industry operate in one of these four main segments, but there are companies that operate in more than one segment. The super majors are the six largest non-state-owned oil companies that do all functions: upstream, midstream, and downstream. The six super majors are ExxonMobil, Total SA, Royal Dutch Shell, BP, Chevron, and ConocoPhillips. It is important to our discussion to highlight the fact that third-party vendors and contractors play a major role in daily operations, and that means there are more available avenues for potential cyber attacks. Also, companies that belong to more than one segment of the oil and gas supply chain are at risk on multiple fronts. The retailer Target was victimized in one of the largest credit card data breaches back in November 2013. It later emerged that the cybercriminals broke into Target's network via a third-party heating, ventilation, and air conditioning (HVAC) vendor that had access to Target's corporate network. Third-party vendors and contractors don't have uniform cybersecurity policies and practices. This creates exploitable weaknesses in the operations chain, as was demonstrated in the case of Target. Everyday mining operations aren't discretely segmented like the oil and gas industry, but nonetheless they extensively employ both contractors and third-party vendors across the production chain. Contractors in turn hire subcontractors, all of which contribute to a challenging cyber ecosystem, especially when the vendors, contractors, and subcontractors all have operational needs to access the mining and corporate networks. Economic factors of mining. Economic cycles. The mining industry is a commodity-centric global player that is affected by the ups and downs of the market-driven global economy. One of the realities the mining industry has to cope with is, commodity prices are subject to significant short-term volatility as well as longer-term cycles. A contraction in manufacturing will result in reduced demands for raw materials and, in turn, slowdown for the mining industry. Conversely, super cycles that generally follow a major event, e.g., post-war rebuilding of infrastructure after World War II, increases demand for raw materials, spurring major growth in the mining industry. The current super cycle, the industrialization of BRIC, Brazil, Russia, India, and China economies is slowing down. This has led to a fall in demand for raw materials and consequently a drop in commodity prices. Falling demands and drop in commodity prices have caused slowdown in the economies of countries such as Australia and Canada, which heavily rely on the export of natural resources. On the flip side, in countries like the United States that are less dependent on the export of natural resources, the drop in commodity prices has had a comparatively smaller economic impact. This economic dimension might at first glance does not seem relevant to any discussion of cyber vulnerabilities. But it is important because it shows how vulnerable the economies of some countries are to any disruption affecting a key contributor of the economy, which can be also brought about by cyber attacks. The following figure shows the main export items that are important for the economies of specific countries. Any resource-rich country that builds its economy on mining commodities would be extremely vulnerable to any interference or disruption in this area. Figure 13. Main exports for United States, Canada, Australia and South Africa in 2014. United States, $1.44 thousand. Machinery and electrical 25%. Transportation 14%. Chemical and allied industries 12%. Mineral products 11%. Metals 5%. Plastic and rubbers 5%. Vegetable products 5%. Stone and glass 4%. Miscellaneous 19%. Canada, $441 billion. Mineral products 30%. Transportation 16%. Machinery and electricals 10%. Chemical and allied industries 7%. Wood products 6%. Vegetable products 6%. Stone and glass 5%. Miscellaneous 20%. Australia $246 billion. Mineral products 59%. Stone and glass 78%. Metals 7%. Animal products 6%. Chemical and allied industries 4%. Machinery 3%. Miscellaneous 13%. South Africa $111 billion. Stone and glass 28%. Mineral products 21%. Metals 12%. Transportation 9%. Machinery and electricals 8%. Chemical and allied industries 6%. Vegetable products 5%. Miscellaneous 11%. Pricing of metals and minerals. The aim of exploration geology is to discover mineralized target areas that can be developed into profitable mines. For today's transnational mining company, this may mean it is cheaper to produce copper from a few large mines in Chile than it is to produce copper locally from many small mines. As extraction costs fall, so do the prices of raw materials, the effects of globalization of trade. Currently there is a shift away from mining higher grade, higher quality ores in politically risky countries to mining lower grade, lower quality ores in politically stable countries. Advancements in technology and the production process have improved yields from lower grade ores, which ultimately makes the mines profitable over their lifetimes. Prices for metals are set according to the weight of a standard unit of refined product. Reference prices for industrial metals or minerals may not be directly applicable to the final product of the mines. Mines will sell their products at different refined levels because of production constraints, transportation capacity, or to meet customer needs. There are two critical dimensions to pricing: transportability, ability to move the mined minerals, and homogeneity, degree of standardization, which ultimately determines the negotiated price between the buyer and seller. The theft of pricing data is one of the goals of threat actors targeting the mining industry. The goals of a cyber attack against the mining industry are different from the goals of a cyber attack against the hospitality industry, espionage versus immediate financial gains. These are some of the specific threats that IT security and the mining industry have to understand when defending their ecosystem. Cyber attacks targeting the mining industry. Why is the mining industry targeted? When we analyze why the mining industry could be a viable and important target, there are three clear factors that explain its relevance. 1. Increasing and continued importance of commodities as traded entities on international markets. 2. Reliance on natural resources for economic development. 3. The need for countries to benefit from their own mineral deposits. The mining industry is both a geopolitical and an economic target. Motivations for attacking the mining industry therefore go beyond any direct monetary value. The most important motivations are the following. Latest technical knowledge and intelligence for competitive advantage. Cyber espionage campaigns against the mining industry are largely geared towards ensuring interest groups have access to the latest technical knowledge and intelligence so they can maintain a competitive advantage and thrive in the global commodities market. The theft of pricing data for metals or minerals is one of the goals of threat actors targeting the mining industry. Having insider information about a mine's pricing data can help a competitor hijack a sales deal by outbidding the competition, or a buyer negotiate a better purchase price or change the terms of a takeover bid, etc. Customer information is another prime target for data theft. Competitors can use the stolen customer information to hijack future sales. Intellectual property, IP, such as production methods, mineral processing methods, chemical formulae, custom software, etc., is a lucrative target for cyber criminals. The theft of IP can drastically reduce the R&D costs associated with developing a new mine. IP theft is commonly done by foreign cyber espionage campaigns, which then transfer the knowledge to their local mining industry. Foreign cyber espionage campaigns are increasingly interested in learning about governance policies, decisions, and decision-making processes of corporate executives. This is because good decisions and good governance policies are critical to the success of any mining operation. The goal is to learn about these decisions and policies and apply them to the local mining industry. Mining companies invest billions of dollars every year exploring potential new mining sites in the hopes of hitting pay dirt, i.e., discover an ore-rich area that can be successfully mined. The exploration phase generates big data sets that the geologists analyze to identify new ore deposit locations. The exploration data is expensive to generate and is key to the company's future growth and success, which makes this data a lucrative target for cyber espionage campaigns. The mining industry is moving towards low-grade, super-large, high-tonnage, and ultra-mechanized operations. This has turned smaller mining operations economically unfeasible, leading to closures, mergers, and takeovers. The fundamental source of a mine's value is its potential ore reserve. Ore reserve and production data are key targets in cyber espionage campaigns, especially when a merger or takeover bid is in the works. The goal is to deflate value if possible or to collect insider information and mount a successful bid. Mine monitoring systems are used for production monitoring, equipment status monitoring, and safety and environment monitoring. There are unified reporting applications that collate, process, and display information from all the different mine monitoring systems. Received data from each monitoring system is fed into a central reporting database and further processed to get the unified picture. These reporting databases are valuable espionage targets for cyber criminals because they provide real-time status updates of the mining operation. Cyber attacks with the intent of weakening a nation's economy. Cyber campaigns can also be used for conducting carefully planned strategic or retaliatory cyber attacks against a key contributor to the nation's economy. The high capital cost and long lifetime of a mining operation leads to lower rates of technological changes. This means mining operations are using equipment and communications protocols that are vulnerable to crippling cyber attacks because standards and equipment upgrades are deemed unnecessary for continued production. Any disruption to the supply chains of the major utilities used in mining, electricity, water, diesel, and compressed air, resulting from a cyber attack or other causes will effectively take the mining operation offline. The supply chain for the 4 major utilities forms part of the Achilles heel of any mining operation. Automation of hazardous, repetitive, and labor-intensive tasks is a key contributor in improving mine safety. Cyber attacks that target automated mining equipment and processes jeopardizes the safety and lives of miners. Any serious disruptions to the operations of automated mining equipment resulting from a cyber attack will take the mining operation offline, causing financial loss and possible equipment damage. Mineral processing is a complex industrial process involving numerous autonomous and semi-autonomous steps controlled by ICS and is designed to achieve maximum yield from the ores. Mineral processing facilities thus face all the inherent cyber security risks associated with ICS. The ROC serves as the nerve center of the modern-day mining operation. Cybercriminals planning destructive cyber attacks against a mining company will attempt to compromise the ROC because the ROC serves as a single point of failure that can take the entire mining operation offline. Third-party vendors and contractors play a major role in daily mining operations, and that means there are more available avenues for potential cyber attacks. Third-party vendors and contractors don't have uniform cyber security policies and practices. This creates exploitable weaknesses in the operations chain. Classic theft of data such as PII, credentials and financial data. Mining companies are also subject to data breaches that threaten all types of businesses, both big and small. The majority of data breaches aim to steal personally identifiable information, PII, financial data, and credentials. PII can be used for committing identity fraud, filing fraudulent tax returns, applying for loans or credit cards, registering fake accounts, selling to marketing firms, and launching spam and phishing attacks. Financial data can be used for creating counterfeit credit cards, paying bills, making fraudulent online transactions, and transferring money out of a victim's bank accounts. Credentials can be used for stealing IP, committing espionage, and launching spam and phishing attacks. There are cases where the stolen data is used in vengeance attacks and/or hacktivism. The victims are blackmailed, or the stolen data is held for ransom payment. The perception of mines as environmental polluters. Some environmentally conscious activists who are protesting the effect mining companies have in terms of environmental damage, wildlife habitat damage and other stated concerns, take it upon themselves to retaliate by inflicting damage to the mining companies. What types of actors are interested? Nation-states. Nation-states as perpetrators of cyber attacks or cyber-based interference might want to gather intelligence and are increasingly using cyber assets as the primary method for this. Governments in developed countries have created sophisticated and stealthy cyber assets that can lie undetected inside organizations for years, collecting and transmitting data. Developing nations are utilizing cyber espionage as a quick and economical way of increasing their intelligence gathering capabilities. Organized cybercriminal syndicates. Intrusions orchestrated by criminal syndicates can be split into two categories. The first category is made up of criminal gangs who steal and sell sensitive information, encrypt sensitive documents and demand ransom, compromise computers and turn them into botnets, etc. The second category is criminal gangs, who have been contracted by national governments to conduct cyber espionage campaigns, or to carry out politically motivated disruptive or destructive cyber attacks, criminals for hire. By using criminal gangs, national governments maintain plausible deniability in case of discovery. There may be some intersect between these two categories where easy profit can be made. Competitors. Competitors spying on each other goes back to the origins of trade. Competitors are interested in information such as intellectual property, production methods, true production capacity, pricing information, customer information, among others. In extreme cases, competitors might launch disruptive or destructive cyber attacks against their competition in order to gain a stronger foothold in the market or overcome a disadvantage. Hacktivists. Hacktivists are internet activists. They attack cyber assets in order to draw attention to their political causes and frequently choose high visibility or high profile targets. Often their targets and their stated causes do not match up. Mining and oil and gas companies are frequent targets of hacktivists protesting the effect they have in terms of environmental damage, wildlife habitat damage, corporate greed, and other stated concerns.